Basic Java structures go straightforward. They start at the top, they go to the bottom. They do their stuff one time. And so unless you explicitly include loops, your code gets one shot at doing stuff properly. So loops are coming in when I know I need to do a set of commands more than one time. I can do it a predefined number of times, like, hey, I want to put 10 plants in the ground. Or I can have it based off of some criteria. Keep adding plants until this flower bed is full, like we see here. But the idea of a loop is it's exactly like every other bit of code. There's a sequence of operations. It's just bounded or grouped together so I know what to do over and over again. So I take some dirt, I dig in it, I put the plant in it, I water it, the seed starts to grow, I get flowers. I take up the flowers, back to dirt. Again, do back, those steps inside of my cycle here. Again, it doesn't really matter which one I do. Java supports either one of them. There's actually 3 different types of loops in Java: the for loop, the while loop, and the do while loop, which is very rare to use, but I'll tell you about it. You might find some use inside of it because it's really the same as the while loop, and just less likely to come into play as easily, as we'll see when we get to that one. For this lecture, though, we're going to focus on for loops. We're going to come back to while loops and do while loops in the next discussion, because we want to be able to just basically focus in on exactly what what the behaviors we're trying to garnish from the for loop, and then let you play with that and then come back to it. So the idea of a for loop is I know before I start generally how many times I want to cycle through something. I have 10 plants to plant. I have 14 students in a class. I want to ask you a question 3 times every single time to make sure you say yes 3 times or whatever. The Java syntax doesn't make it super clear that that's what's going on. There's other languages that are a bit more explicit, but that's the intent of this. Is when I can figure out how many times I want to do something, the syntax makes it a little bit easier to follow that that's what going to happen. The way Java breaks it down is there's 3 parts to the for loop. There's the initialization part. There is the check, and then there's the enhancement that's going to happen here. So the code we see here, the output is, and it goes through this code 10 times. It starts with the number 0, because I is starting with number 0, and it prints out 0. And then it checks, is 0 greater than 10? No, it's not. So we're going to execute the code, prints out 0, then comes back around, and at the end, it does the advancement, I++. So then I becomes 1. So I is 1 less than 10? Yes, it is. Print it out. 1. I++, I becomes 2. So the plus plus is the same as saying I is equal to I plus 1. 3, 4, 5, 6, 7, 8, 9, and then it gets up to 9. It says I plus 10. Is 10 less than 10? No, 10 is not less than 10. 10 is equal to 10. And so the code stops at that point. After it does the loop 10 times, 0 through 9 times, then it continues on after that final curly bracket. So as I said, the for loop has those 3 distinct parts: initialization, the decision, and the advancement. We can do all sorts of crazy things with each of these spots, but the best for loops keep it simple. Sometimes we need to make it more advanced. Sometimes we have to do some of these other advanced stuff, and that's why it's there. That's why it's capability. But we don't want to make it any more advanced than it needs to be. Keep it simple, but no simpler than your logic allows. So it is possible to do things like this. I can initialize a variable before the statement, and I can ignore the advance or declare it outside of it and do the initialization up front. The reason I would do that is because that index variable disappears once the for loop is over with. It's only visible inside the curly bracket. So if I want whatever the last index was be to use in the logic that follows, I could identify it like this. And initialize, advance, and every so often. Or more commonly, what I do is I create my index variable right here. The index I into I, integer number, I is equal to that. Now, it doesn't have to be an integer. It could be a double, could be a Boolean, could even be a string in theory that goes along here. It's just whatever that variable is going to be. Most commonly, you'll see an integer inside of that, maybe a long in certain cases. All right, so both of these are perfectly valid syntax. Both of these would run just fine. The stuff that happens in the loops come back to those curly brackets. I keep emphasizing this, but curly brackets are really important in Java. Lining up those curly brackets are really important, and indenting the code between the curly brackets is stylistically important. important. Not compilation important, but it is important stylistically. So once we have the variables initialized, and we're just hiding it with dot, dot, dots. It's not that they don't exist here. We're just focusing on the next part. We have some decision. And the decision can be very simple. I is less than 10, like we first saw. But anything that results in a single Boolean, just like in a if then else statement, anything that results in a single Boolean can be used here. So if it's less than 10 and it's not quitting time. So the time is not equal to quitting time. So you can see I can use the and, I can use the or, whatever results in a single Boolean. Best loops, keep it simple. Counting up to an answer at the end. And then the last part's the advancement. Again, ignoring the other two parts for the moment. Most typical is I plus plus or I minus minus. I is equal to I minus 1. 0, 1, 2, 5, 6, 7, 8, 9, 10. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. I can do any statement that qualifies there. I don't need to put a semicolon after it. You can see in this case. But I is equal to I plus 3. I is equal to I plus 1. I is equal to I times 10. I times equals 10 is the same sort of thing inside of there. There's all sorts of things you can do inside of there. You could call a method inside of there to look up I and advance something. There's all sorts of things that are allowed. The best for loops, keep it simple. I'll keep saying that over and over again. So the full for loop syntax actually allows for multiple variables inside of there. If for some reason I have an I and a J, and they can both be incremented on the same cycle, the same scale. Again, it's very rare to run into this, but so for I and J both start at 0. So it'll continue to loop while I is less than 10 and J is less than 15. I can say I plus plus, J is equal to J plus 3. So they go on different scales. You can figure it out that I will do it 10 times. J is advancing 3 times, so only do it 5 times or maybe 6, depending on where it is. So this actually won't, it'll stop when J gets up to its number. But the J number could be modified based off of what's happening in the logic. These variables are not constant inside of the for loop, as some languages make them. I could be updating I and J based off of other things that are happening. I could be modifying those values based off other things that are happening. So that's why you might have this complicated logic. Not likely, but it's possible inside of Java. So the best for loops are simple. They can have any number of indices. They can have any decision logic. They can increment and decrement in any imaginable way inside of there. But what makes them powerful is when they're predictable. I know how they're going to execute. It's really easy to understand them. The more complicated they become, the less readable they are. At that point, they probably should be while loops on their own. We'll talk about while loops in the next one, as we said. But that's the foundation of the for loop. There's actually some advanced syntax in the for loop that will allow you to do some even funner, crazier type stuff that makes it even simpler when you get into using arrays and you get into using collections and stuff like that. We'll put that off till we discuss what those things are. But the for loop within that makes it even simpler than I just say, hey, I have this list of things, like a list of students for each student. That's where it becomes really powerful. That's where the for loop really is useful. That's where you'll see most of your for loops in modern Java in use. But if I do need an index variable, if I do need to track, this is the number 1, 2, 3, 4, 5, this is the way you'd typically see it. So write the logic you need, just keep it so it's very easy to understand, read, and maintain. Sometimes that is done well through the complex for loop. Often it's much easier to describe that within a while loop. So go play the for loop. Get a feel for that, then come back and we'll talk about while loops next.